Let us start with a new section, scanning and enumeration. In this lecture, we are going to learn an overview of network scanning. So what is scanning? Scanning is a set of procedures for identifying live hosts, ports, services, discovering operating systems, architecture of target system, identifying vulnerabilities and threats in the given network. Network scanning is used to create a profile of the target organization. Scanning refers to collecting more information using complex and aggressive reconnaissance techniques. So what are objectives of network scanning? To discover live hosts and computers, IP address, open ports of the target victim. To discover services that are running on the host computer. To discover the operating system and system architecture of the target. To discover and deal with the vulnerabilities in the live hosts. Every organization has a network. This network could be an internal network which consists of all the systems connected with each other, or it can be a network that's connected to the internet. In either case, to hack the network, you will have to find a vulnerable point in the network that can be exploited. Network scanning is used to find such vulnerable points. So, how is network scanning different from information gathering? Well, think of it as like this. You are an army officer and you and your team are planning to attack a terrorist lair. You have found out the location of the lair and details about the surroundings and also the ways to send them to the lair. You can consider all this information you have gathered using the information gathering phase. Now, you have to find the point through which you can enter the terrorist organization and attack the enemy. This is network scanning. In simple terms, information gathering is used to gather information and understand your target, and network scanning is a method used to find possible vulnerable points in the network through which you can hack the network. Depending on what kind of information the scan identifies, network scanning can be classified into two types: port scanning and vulnerability scanning. For learning the network scanning phase, you need to learn TCP connection establishment, also called as three-way handshake. TCP three-way handshake is a process which is used in a TCP/IP network to make a connection between the server and the client. It is a three-step process that requires both the client and server to exchange synchronization and acknowledgement packets before the real data communication process starts. Three-way handshake process is designed in such a way that both ends help you to initiate, negotiate, and separate TCP socket connections at the same time. It allows you to transfer multiple TCP socket connections in both the directions at the same time. The TCP traffic begins with a three-way handshake. In this TCP handshake process, a client needs to initiate the conversation by requesting a communication session with the server. So, how is the process of three-way handshake? In the first step, the client establishes a connection with the server. It sends a segment with the SYN, that is the synchronization packet, and informs the server about the client that when should the communication be start. With that, the client also sends the sequence number. In the second step, server responds to the client with SYN-ACK signal, that is synchronization and acknowledgement. Acknowledgement helps you to signify the response of the segment that is received. In the final step, the client acknowledges the response of the server and they both create a stable connection will begin the actual data transfer process. So let us have a summary of a TCP handshake. In the first step, the client establishes a connection with the server. In the second step, the server responds to the client with SYN-ACK signal set. And in the final step, the client acknowledges the response of the server. In the last slide, we saw the TCP three-way handshake process initiation. In this slide, we will see TCP connection termination. For terminating the connection, client sends a FIN segment. FIN stands for finish to the server with FIN bit set to 1. Client enters the FIN wait state 1. Client waits for an acknowledgement from the server. After receiving the FIN segment, server frees up its buffers. Server sends an acknowledgement to the client. Server enters the close wait state. After receiving the acknowledgement, client enters the FIN wait 2 state. Now, the connection from client to server is terminated. That is, one-way connection is closed. Client cannot send any data to the server since server has released its buffers. Pure acknowledgements can be sent from the client to server. The connection from the server to client is still open, that is one-way connection is still open. Server now can send both data and acknowledgements to the client. Now, suppose server wants to close the connection with the client. For terminating the connection between server and client, server sends a fin segment to the client with fin bit set to 1. Server waits for the acknowledgement from the client. Note, if server wanted, it could have sent the fin segment along with the previous acknowledgement that it sends to the client. After receiving the final segment, client frees up its buffers. Client sends the acknowledgement to the server, which is not mandatory, and then client enters the time wait state. So what is time wait state? The time wait state allows the client to resend the final acknowledgement if it gets lost. The time spent by the client in time wait state depends on the implementation. The typical values are 30 seconds, 1 minute and 2 minutes. After the wait, the connection gets formally closed. In the next lecture, we will see different scanning techniques.